question of whether it's legal to have more than 4 offsets in a run of conduit, even if the total degree of bends does not exceed 360 degrees, is addressed directly by electrical codes. The answer is no. Electrical codes, such as the National Electrical Code, or NEC, specifically limit the number of bends, including offsets, allowed in a single conduit run. The primary reason for this limitation is to prevent excessive pulling force on conductors during installation. More bends increase friction, making it harder to pull wires through the conduit. This increased friction can damage the conductor insulation, leading to potential short circuits, ground faults, and ultimately, electrical fires. The NEC doesn't just consider the total degrees of bend, but also the number of bends. This is because each bend, regardless of its angle, introduces some amount of friction. Even small offsets contribute to the overall pulling force required. A specific rule is designed to balance the need for practical conduit routing with the safety and longevity of the electrical system. The limitation on the number of bends helps ensure that conductors can be easily installed and maintained without damage. Several factors contribute to the importance of adhering to the conduit bend rules. Firstly, conductor insulation is vital for preventing electrical faults. Damaged insulation can lead to current leakage, creating shock hazards and increasing the risk of fires. Secondly, excessive pulling force can stretch and weaken conductors, reducing their current carrying capacity and increasing their resistance. Thirdly, difficult wire pulls can lead to shortcuts and improper installations, compromising the overall safety and reliability of the electrical system. Understanding the NEC requirements for conduit bends is crucial for electrical contractors and installers. It ensures compliance with safety standards and helps prevent future problems. When planning a conduit run, consider the route carefully to minimize the number of bends and offsets. If more than 4 bends, including offsets, are necessary, consider using pull boxes or junction boxes to break up the run into shorter segments. A pull box is an enclosure installed in a conduit run to provide access for pulling conductors. It allows installers to pull wires in shorter, more manageable sections, reducing the overall pulling force. Junction boxes serve a similar purpose, but they also allow for splicing and terminating conductors. When using pull boxes or junction boxes, ensure they are properly sized to accommodate the conductors and splices. The size of the box is determined by the number and size of conductors entering and leaving the box, as well as the number of splices. The NEC provides detailed requirements for box sizing in Article 314.16. Another important consideration is the type of conduit being used. Different types of conduit have different bending characteristics and requirements. For example, rigid metal conduit, or RMC, typically requires specialized bending equipment and techniques, while electrical metallic tubing, or EMT, can be bent with simpler tools. The NEC provides guidelines for bending different types of conduit in Chapter 3. When bending conduit, it is essential to use the correct tools and techniques to avoid damaging the conduit or reducing its internal diameter. Damaged conduit can be difficult to work with and may not provide adequate protection for the conductors. The internal diameter of the conduit must remain consistent to allow for easy wire pulling. Proper bending techniques involve using conduit benders that are sized correctly for the conduit being used. These benders create smooth, consistent bends without kinking or flattening the conduit. When making offsets, it is important to ensure that the offsets are parallel and that the conduit is properly supported. Misaligned offsets can create stress points and make it difficult to pull wires. Conduit support should be installed at regular intervals to prevent sagging and to maintain the integrity of the conduit run. The NEC specifies the maximum spacing for conduit supports based on the type and size of the conduit. In addition to limiting the number of bends, the NEC also specifies the minimum bending radius for conduit. The bending radius is the distance from the center of the bend to the inside edge of the conduit. The minimum bending radius is determined by the size and type of conduit and is intended to prevent the conduit from kinking or collapsing during bending. The NEC provides tables listing the minimum bending radii for different types of conduit in Chapter 9. When making bends, it is important to avoid exceeding the maximum allowable bend angle. Excessive bend angles can reduce the internal diameter of the conduit and make it difficult to pull wires. The NEC does not specify a maximum bend angle, but it is generally recommended to limit bends to 90 degrees or less. In situations where multiple bends are required in close proximity, it may be necessary to use factory-made elbows or sweeps. These fittings provide smooth, consistent bends and can help reduce the overall pulling force. Factory-made elbows and sweeps are available in a variety of sizes and angles to accommodate different conduit routing requirements. When installing conduit in wet locations, it is important to use watertight fittings and enclosures. These fittings prevent water from entering the conduit system and damaging the conductors. The NEC specifies the requirements for watertight installations in Article 314.15. In corrosive environments, it is important to use conduit and fittings that are resistant to corrosion. Common types of corrosion-resistant conduit include PVC-coated steel conduit and stainless steel conduit. The NEC provides guidelines for selecting appropriate materials for corrosive environments in Chapter 3. When installing conduit underground, it is important to bury the conduit at the proper depth to protect it from damage. The NEC specifies the minimum burial depths for different types of conduit in Article 300.5. In areas subject to heavy traffic, it may be necessary to encase the conduit in concrete for added protection. When running conduit through fire-rated walls or floors, it is important to maintain the fire resistance of the assembly. This can be accomplished by using fire-stopping materials to seal any openings around the conduit. The NEC provides guidelines for fire stopping in Article 300.21. It's also important to consider the expansion and contraction of conduit due to temperature changes. Long runs of conduit can expand and contract significantly, potentially causing stress on the conduit and its supports. Expansion joints can be used to accommodate this movement and prevent damage. The NEC provides guidelines for expansion joints in Article 300.7. When planning a conduit installation, it is always best to consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and standards. A thorough understanding of the NEC and local regulations is essential for ensuring a safe and reliable electrical system. Ignoring these rules can lead to code violations, costly rework, and potentially dangerous conditions. Therefore, adhering to the 4-bend limit, including offsets, is not just a suggestion but a mandatory requirement for compliant and safe electrical installations. Remember that each offset counts as a bend. So, planning the conduit run carefully, utilizing pull boxes when needed, and sticking to the 4-bend limit are all crucial for a successful and code-compliant installation.